So one thing that we can do is we can see how the different star systems are angled in three-dimensional space. So if I go here to Sirius and just sort of have a look around, I don't know why Sirius B is inclined so steeply. But now if I turn around and look at the Sun, and start heading toward the Sun, Sirius appears south of the plane of the solar system, and Earth is kind of tilted towards it, so it's not as far south from our point of view as it would be from most of the other planets. So right now I'm watching this distance number over here to see it decreasing. And I'm just speeding up towards the Sun, accelerating. And we're getting close. It's going to slow down automatically so we don't overshoot. Hopefully don't overshoot the Sun. It's very easy to overshoot your target in this program. But first we see some Kuiper Belt objects, and it looks like there's a bug in the orbit of one of them. The lines are all angled and they should be. That's because of the eccentricity. Now that I think of it, it's doing linear time steps, not doing linear angle steps, and that's why we see those lines. But now we're getting in closer where we can see the orbits of the major planets, and we see that they're inclined quite a bit relative to where we just came from, which was Sirius. And some of the planets we can even see the orbits of their moons. So I'm going to pull up the System Explorer here, and I'm going to look at Earth. I'm going to track Earth. And now I'm still watching this distance. I don't know where my mouse is. Still watching this distance up here to make sure that we don't overshoot the Earth. We're close enough now we can resolve the moon. And we can see the moon's orbit. And now we see the Earth kind of tilted on its side because the Earth's north is more or less to the right from here. And it's a little bit slow to render. It's not good resolution on that disc, not good quality. But that's because my machine is kind of an old piece of junk. We're gonna crash. Oh no, we're gonna crash. And okay, now we landed. Looks like we're near the North Pole. Okay, we're 62 degrees north, so we landed. So we landed on Earth. So now if I go to Sky Atlas view, I'm going to see the sky relative to the Earth's plane, the plane of the Earth's equator. So I see Polaris is right there by the celestial North Pole. And if I look south, I see Octans. Octans by the South Pole. So now let's go to another star, and I have it already ready to go to. Gliese 67, also known as GJ 67. I'm going to look here at the local system explorer. This is a binary star, and the orbit of the binary is known. The orbit of the companion around the primary is known. So the way this is inclined in space, we look up, we see Orion and the direction of Lepus, and we look south, and we see it's kind of in the direction of maybe Hercules. Yeah, that's the star in Hercules, 325 light years away. And then 662, so the South Pole points more or less towards the direction of Hercules. So this orientation in space is known, at least for the companion revolving around the primary. Does the primary have any planets? It doesn't have any known planets. Probably doesn't have planets because the companion has an eccentric orbit, brings it kind of close to the primary, so it'll be hard for planetary disk to form and coalesce. But if it does have planets, do they orbit in the same plane as the companion? Probably not. It seems to be pretty common for planets to not orbit in the same plane as the companion. But regardless, we see a very bright star here, very close. 3 light years, negative 1.8 magnitude. Upsilon Andromedae, and I can even go look at the stellar neighborhood and find that this is the closest one. It's the closest star to this system. This is their Sirius, and then right below it we see Beta Andromedae, magnitude 0.1. So this is like their Sirius, and this is like their Vega. But if there's any planets in this system, they would see the 2 stars right next to each other in their sky. So I'm going to track Upsilon Andromedae and head for it. And something nice about Upsilon Andromedae is we have inclinations and longitudes known for 2 of its 3 planets. So as I head there, we'll see, first we'll see the planets. And then we'll look at the poles in 3-dimensional space from the system. But we're getting close. We just surpassed a light year. Closing in thousands of AU. Now we're in the hundreds of AU. Now we see the names of a couple of the planets now. They're kind of overlapping. And as we get in closer, now we can make out 2 of the names. We can see there's 3 planets. And we can see how the orbits are inclined in space. And now this is relative to the ascension and declination lines that we see. The grid lines are for Gliese 67. So relative to that star, the Upsilon Andromedae system is standing up on end. So I'm going to stop here because now we see that 2 of the planets are actually inclined pretty strongly. It's a pretty good inclination relative to each other. It's about 23 degrees. It's about similar to the inclination of the Earth's equator to our orbit around the Sun. And then for this innermost planet, the inclination isn't known, so the program just assumes that it's in between the other two. It does a system-wide average. But I'm going to stop tracking, and I'm going to use the System Explorer. We find one of the planets, the outermost one, is in the habitable zone. So I'm going to track that. And yeah, I could just press O and go directly to it, but it's more fun to crash into it. So it looks to be an ice giant, but a temperate ice giant. And oh no, we're gonna crash. Oh no, here it comes. Oh, that's bright. And now I've landed on the night side because there's a bug in the program. There's 1,000 bugs in this program. And we're not too far from the day side. Let's trek over the day side. Is anything happening? It's slow to get there because it's such a big planet. It takes a while to trek over the day side. This is still in twilight. Oh, we got something. Okay, we're on the day side. Just past the Terminator. So the program has given the planet an overcast sky, thick atmosphere, which is consistent with it being an ice giant, so we're not going to see any stars or other planets through the clouds. Just when we move the view, we can briefly see through the clouds, kind of, and through the ground. But look at the inclination on that orbit. It's so pronounced. So now if I go back to Sky Atlas and look north, now we see Gliese 67. And it's way up there. It's 68 degrees north, 68.5 degrees north. Magnitude -0.8. So this for them is in between how Sirius and Vega look for us. Whereas if you remember when we were there in the Gliese 67 system, Upsilon Andromedae, look, it was just above the ecliptic.